might reboot it. So this console's gone. CD music royalty free. Yeah, I think I'll play some music until they're viewers, but just there they are, seconds. No, no. The Gronus group is. It's a lot of companies, a lot of well-known companies that wrote it. I'm going to do a lot of thinking, I think. Maybe I should just write a README. I already have a README here about the descriptors, but let's make a new README. Yeah, I don't even know what the extension is, so just let's call it README. So, bindings. I wrote on my whiteboard, which is behind me, you cannot see it. Yeah, we have descriptor. You have descriptor layouts. So let's say we have the descriptor layouts. We have pipeline layouts. We have shader resources. And in my test application I have two pipelines. So let's call them just simply pipelines. There's a difference between a pipeline layout and a pipelines. In my test application I'm going to have only one pipeline layout, but we are going to have two pipelines. I'll call these things with an abbreviation: scripter layout, pipeline layout, shader resources, and let's call these then pipeline 0 and pipeline 1. I use a NeoVim and hi. I'm not streaming on Twitch. No, I could do that, but I don't know if I can do that at the same time. Does it make much sense? I don't know. Okay, so what is a descriptor layout? Well, I'm talking explicitly about my test application because that's the only experience I have. I have a I have a descriptor layout with a uniform buffer, and let's call that a U, and a texture. So let's say I have one that is a texture plus a uniform buffer, and I have a layout that is just a uniform buffer. Going to make an ASCII art table. Maybe I should just make a picture of my whiteboard and show that. There's also lots of errors which I will not be able to draw here. Okay, so then we have the pipeline layout, and the only pipeline layout that I have is the T plus U one time, and the U 2 times. And this whole thing together is we should remove the empty line here. This whole thing together is one pipeline layout. Okay, then I have following shader resources. Yeah, uniform buffer for the top coordinate. Let's call that UT. And a uniform buffer for the left coordinate, and a uniform buffer for the bottom coordinate, and a texture. That's the shader resource that we have. Then I have a pipeline 0. And another pipeline, it's pipeline 1. And the main difference here is let's see. The main difference is that they use different shaders. So this one has 2 shaders, a vertex shader, vertex shader 0, and a fragment shader 0. And this one has a fragment shader 1 and a vertex shader 1 and a fragment shader 1. Okay. Now I did draw a lot of lines with on my whiteboard, which you cannot draw here, but we can do it differently. Clearly this TU here is just repeated here, so the TU is that TU. This is the same thing. And this is also a layout, so I have a layout and I'm using that here. Yeah, ASCII art is not very clear sometimes, like this. Okay, that's an arrow. We have only one pipeline layout. Why? Because let's see, how did I draw that? Okay, below the pipelines I have drawn, I have the T plus U layout, and I have 2 uniform buffers. So these are descriptor set layouts. This descriptor set contains, let's say this is a descriptor set number 0, and descriptor set number 1, and descriptor set number 2. And they are numbered like that simply because I have this order. So I pass these 3 things to the pipeline create function. And the order that I pass them in determines the number of the set. Furthermore, we have here, well, we can have anything, but the original test, where I was just trying to figure out how it worked with set numbers and binding numbers. I didn't know how it worked, so I just thought, well, let's try something that is a bit from everything. And I swapped the top and the left, meaning that this is a uniform buffer and this is a top plus U, and this is the U, meaning that although they use the same pipeline layout, the numbering of the sets are different. Because, yeah, well, I mean, there's a different pipeline, so I can do 2 calls to create pipeline. And let me have a quick look. I think this hack 12 point. Oh, the font is a bit small, sorry. I should switch to YouTube. And I might have a different font here. Appearance. This font is Deja Vu Sans Mono 16 point. And the other one was a hack 12 point. On Arch Linuxes. Okay, so I have 2 pipelines, so I create. Oh, now it doesn't really look like it did look before. Did something like this? No. So I create this pipeline by passing them in this order, and I create the pipeline 0 by passing them in this order. Then why? Well, I can do that. So then set number 0 is T plus U for pipeline 0, and set number 1 refers to the T plus U for pipeline 1. Now the bindings are more interesting because, well, obviously this T is linked to that T and also to this T. You say why? Well, I only have one resource. I mean, for those who don't know how application looks like, it doesn't run anymore, right? Assertion VK header failed. What does that mean? I'm assuming some library or the compiler or so was upgraded, because I rebooted after an upgrade. So there was a version mismatch, and hopefully I get not the same error after this recompile. Okay. Oh well, only the second time it really works. So what I have is a triangle with a single texture and 3 uniform buffers called top, left and bottom. Each uniform buffer contains a single float that they can change here with the DRI GUI interface between 0 and 1. The uniform buffer is then transferred. I write to this value is written to on the CPU, of course, to the uniform buffer, which is then transferred to the GPU. And the shader just reads the float in the uniform buffer and uses it as the X coordinate of the top of the triangle. So it's sort of hard-coded the point of the triangle, and it draws a single triangle. This is super simple vertex shader. This is one pipeline. So one pipeline simply uses the coordinate from 0 to I think 1/2. So it divides it by 2. The coordinates run from 0 to 1 always, and I think from 0 at the top to 1 at the bottom. So since I pass 1 and I don't want it to get past the half of my window, I have to divide it by 2. This one is from -1 to +1. So that one must be must add 1 and then divide it by 2 in order to let it run from. Oh wait, maybe 0 is in the middle. It runs from -1 to 1. I'm not even sure. I think it's from 0 to 1. Anyway, just map them such that the pipeline number 0 draws it here, and then pipeline number 2 is a different shader, and that shader also adds 1/2 to the X coordinate of the points. So pipeline 2 draws on the other half simply because it adds 1/2 to all the X coordinates. I think that the shader of pipeline 2 also has the top and the left swapped. So it uses, but that was not really top and left. Of course, it's more the set number. And now I'm generating it. It's not really the case anymore. Depends on what the Vulkan engine is generating, what the set number is. So. Anyways, I put the top. The top is the U and the texture in a single. I meant here that this is just a uniform buffer for the top coordinate. Maybe we should use a small lowercase here. So I do put the texture and the uniform buffer that I use for the top coordinate in one descriptor set. And the other two are the bottom and the left descriptor set only contain a single uniform buffer. That means that we have only 2 descriptor layouts, because there is no difference between left and bottom. They only contain one descriptor set, a uniform buffer. The pipeline layout, however, contains 2 of those, because in total I need 3 uniform buffers, right? Okay, if a descriptor set contains only a single descriptor, like in this case, then the binding number of that is always 0. So we add that binding number, let's say, I don't know, think of a notation. Let's call it dot. So this is dot 0, and this is also dot 0. There is no other way. That's dot 0, and this is dot. That's not true. This is dot 0. But here we have 2 of them, and that could be dot 0 here and dot 1 here, or the other way around. Let's say I use the other way around here, dot 1 and dot 0. So that would mean that in this set, the texture is binding 1 and the uniform buffer is binding 0. And in this set, the texture is binding 0 and the uniform buffer is binding 1. But is that possible? I could swap the set numbers around, because that's simply the order in which I pass these things when I create the pipeline. Although even that is, and I'm now not feeling very certain about, I must say. No, I think that the pipeline layout is created like that. Yes. So the set number is already determined by the pipeline layout. And since I have only one pipeline layout, that would be then like this. And then obviously we also only have a single way to number the bindings, either 0, 1 or 1, 0. There is only one set 0. But then for a moment, let's assume that I even create 2 pipeline layouts. So I do have this option. Let me try to make a nice copy of this whole column. So this is not really the case for the current application, but if we make 2 pipeline layouts, is it then possible to also change the binding or even just the binding? We begin with the binding, and this is what I want to answer for myself at this moment. I think it's not possible, but who am I to know, right? Okay, so I was assuming, and I think that's right, so it's a good beginning hypothesis, that this is what is determined by an created pipeline layout. Not just that the texture and the uniform buffer are in one set, but also which set it is, and also which binding numbers it has. And to find out if that is correct, I guess we just should look at the source code and see where the pipeline layouts are exactly created, and then what goes into that in terms of numbers and stuff. Let's just write this. Okay, now I try to never use abbreviations, and I try to use the most logical names. So I would say that creating a pipeline layout uses the function name create pipeline layout, and that is the case. And we see here a declaration because it's a header file. Then this is the definition, but it's probably more interesting to look at this line where the IMG is using create pipeline layout, or maybe I should look at this line. The Linux viewer application is and despite its name, really just a triangle, single triangle. So it cannot, we should not look at that one. And this is part of the Vulkan engine that I'm writing. So that's really the code that I want to look at. I mean the IMG also, but it's kind of separate. So this is the only place where we create pipeline layouts, and what is being passed. Well, information about push constants, but I'm not concerned with that at the moment, and information about descriptor sets. And what is being passed is a Vulkan handle vector of realized descriptor set layouts, where realized is an invention of me, meaning that it is made concrete. The descriptor set was actually created. So we do have a Vulkan handle for it, as the prefix already suggests, by the way. So maybe the whole realize is not necessary. Well, I guess that already says it. What we pass are handles. So everything is known that was known at the moment that we created the descriptor set layouts themselves. However, it is also a vector. It is a standard vector. Here it's defined here. And I'm pretty damn sure that the order of this vector is what determines the set numbers. So the set numbers can be different, but the binding numbers cannot, because they are not passed here. They must be part of the descriptor set layouts. Let's verify that. So now I'm going to look for the place where I'm creating the descriptor set layout itself. And let's guess how that function is called. Create descriptor set layout. Yay. Hit in one. And that one is created here. This is a definition. This is also a call. You have to, again, in IMG a call and then in the engine. Okay, it is being created here with, as information, a sorted descriptor set layouts binding thing, which has the type, also a standard vector. Now in this case, at first sight you would think, well, then the order of this vector matters and maybe that determines the binding, but that's not the case for creation of the descriptor set layout. Because the binding number is actually hard-coded in the things that you pass here. The descriptor set layout binding is a Vulkan struct which contains, defined here, and the variables are at the bottom. Here you see all the variables that go into it, and that includes the binding number. So that should be 0 for the descriptor set layout that only contains a uniform buffer, and it should be 0 or 1 for well, a 0 and a 1 for the other one. For example, this is 0, this is texture, and this is fragment shader. Or this is 1 and this is uniform buffer, and this is vertex shader. And the 0 or the 1 can be 0 or 1 in both cases. So yeah, that is hard-coded, and in the as soon as we call this, the binding is set in stone. The binding numbers. So this comment is not really correct, because the binding numbers must be correct here, because the binding numbers that are used become set in stone here. So the comment is actually correct. Not set seems a bit unlikely. Let's make it just not correct. So they more like attention, the binding numbers must be correct here. Cannot change them later. But okay. Then I'm gonna go back to my README. So the binding numbers are already fixed at the moment that I create my descriptor set. Descriptor layout. So let's say this is then, well, pick something, 0 and 1. Hide tag table. Well, let's call this one, this must be a dot 0. Yeah, right. Okay. Well, that means that I can create these things only with the same binding numbers. But possibly I can still swap left and right. Top and left. Hello. Left and right, there's no right. So if I swap the top, then I must use the top is T plus U, so there's no other option. Now this is all the information that is in the layout, and in fact set number 1 and 2 use the same handle. So these two are actually the same handle because they're just the same layout. And also these two, of course, are the same handle. And if you look between them, they're also the same handle because, well, I have just two things. Maybe I should give there a number, as in a handle number. Let's shift the whole thing a little bit. So I give these a handle number. Let's say this is handle number 0 and this is handle number 1. Then what you really have is a layout that uses handle 1 for pipeline layout number 0, and then I'm doing it wrong. That was handle number 0, and handle number 1 is used for the other two. And pipeline number 1 uses the same handle, the same two handles here. So as you can see, there is absolutely no information in the pipeline layouts about top. Well, top maybe, because we know that the top is in the same descriptor set as the texture, although that's rather arbitrary also. We definitely do not see any difference between the other two, so that we cannot know what is left and what is bottom, or what is top and what is bottom. So when does that come to life? Well, that happens. I'm going to shift this also a little bit. It's probably not the smartest thing to do. Is there no column? Here's a column. Nice column with just 2 vertical lines. Let's put that here. Or here. Right. Okay, that is linked at the moment we update the descriptor set. So there is a somewhere we call update descriptor set, which I guess has a function called update descriptor set. Maybe descriptor sets. I can even jump to it from here. It's not there. Descriptor set. Okay, we have an update descriptor set. At the moment we call that, we link a descriptor set, so that would be handle 0. No, that's not possible. Sorry. Hashtag 0, I meant. The descriptor set is numbered by 0, 1 and 2, right? I don't think there's a very good site about it. You can Google Vulkan tutorial and then you will get some information, but in the end it's a study of a year at least. So I would say you start learning Vulkan, and then you'll, in a year or so, you'll maybe get an idea of what you just asked. Starting with a tutorial, especially for that question, is a good thing, I think. But I don't like the tutorials in that they are simplifying things way too much, which causes you then, if you use the example code that Vulkan tutorials are using, then you get confused because real life is much more complicated. I think it really slowed me down. I had to figure out all the details myself, because I just leave it out in the tutorials. What do I say? I'm still figuring it out. That's what I'm doing now. Okay, so there is an update descriptor set thing, and that links the actual shader resource to something. But to what? Because what I would like is that this thing here is linked to, I'm gonna need way more room, right? Let's shift this whole thing really up a lot. Give me space. So what I would like is that this thing is linked to, maybe that's a nice arrow to use for the linkage between shader resource and the layout. or the descriptor set. I don't know. I want this to be the uniform buffer left. And I want this to be, yeah, well, both really. So this must be the texture and the uniform buffer top. And this must be linked to uniform buffer bottom. Yeah, let's remove that. Inventing notation as we go. So I don't know if it's possible, but the original application before I generated everything, I just hard-coded everything manually so I could do whatever I wanted. And I completely swapped the top and the left coordinate in terms of set. So this would still be the top coordinates and the texture, and this would be then the left, and the set number 2 is still the bottom coordinate, so the uniform buffer bottom. The U stands for uniform buffer, T stands for texture, lowercase t for top, L for left and B for bottom. Okay, so we probably have a few new viewers, so I'm quickly going to show the application again. So we have two pipelines. One pipeline draws a triangle on this side and the other pipeline draws also a triangle, but it adds a half to all the x coordinates, so the triangle ends up here. And each pipeline uses one texture, which is the same texture handle. And they use each 3 uniform buffers, which is the same uniform buffer, really. Well, in terms of shader resource anyway. So we have just 3 uniform buffers, each with a float in it, and the float, I can change the float. And they use this value for the x top coordinate, this value for the y coordinate of the left corner, and this value for the bottom x coordinate. Now the question is it possible that we swap the descriptor set numbers 0 and 1? In other words, where exactly is it determined that this is descriptor set 0? Specifically for the very recognizable descriptor layout with both a texture and a uniform buffer. Well, that was at the moment that the pipeline layout was created, right? That's why I'm putting it here and not on the other side of those arrows. Let's first verify that the set is indeed determined at the moment that I create the pipeline layout. So I'm going to look at the source code, create pipeline layout, and that is again called here. Yeah, well, we were just here, and the order of these elements of this vector here determine the set number. So I can have them. They can have different set numbers, but only if I create different pipeline layouts. The test application only has a single pipeline layout, so I cannot swap. I must say it's confusing me because I'm pretty sure that before I generated it, I did swap it, and I also had a single pipeline layout. So now I have to verify how many pipeline layouts I have. Maybe I should just look at the number of times this function is being called. Oh, it is called twice. Yeah, it is called twice. I do have 2 pipeline layouts. Why did I get confused about that? I guess it's still good to look. I'm not going to look in the log file. I'm going to look in the source code to see if I can figure out how often it is being called. So that would be by the factory here, pipeline factory. Well, we have 2 pipeline factories, so it already settles it, I guess. Yeah. The pipeline layout is created at this point, which is in the factory, pipeline factory. We have 2 pipeline factories, so definitely being called twice. So this is the user code. The user has to do very little work. That was the whole idea of the engine, of course. We create here manually 2 pipeline factories. Simply by stating that we create a pipeline factory for this graphics pipeline. So this factory creates this pipeline. Which is just a handle. It's an object, it's an instance of a certain class, and the instance stands for that pipeline. It's not really the Vulkan pipeline, it's probably even const. So the user creates 2 pipelines in this case. Say I want to have 2 pipelines. So it's basically translated to English, this says I want to have 2 different pipelines. But these classes contain they do wrap the handle. Well, okay. So they really contain the Vulkan handle and a little bit more information, which is, I think this handle exists of two indices that can be used in certain vectors to get information about the creation of the pipeline. And other information that I store. Same thing here, we have 3 uniform buffers. And I do tell it that it is using 3 different structs, even though each struct is containing a float. You're only using this float here for the x coordinate. This padding is needed, and this is just an unused matrix that I put in that struct. And the left position is something like it. a different matrix, but it has also a float in it for the Y position, and it's called Y here. And the bottom position is, again, it's not a matrix but a vector which is unused, and an X coordinate, which is a float. I could have used 3 times the same structure and then just put a float in it, of course. But, well. It also says that I'm going to use 2 pipeline factories. And now we have all the instances of objects with certain type that we can create, kind of like building blocks that we create our application with. So the factory handle is just a wrapper around the pipeline factory index, which is just a size type. And that can be used into certain vectors. Okay, so that when we really get started, it says pipeline factory number 1 it must be created, please. And I'll link it to the graphics pipeline. So this factory is going to create this graphics pipeline. There's a special line here. I need to keep it alive because I get information from the factory after the factory normally would have been destroyed already. So this line just keeps it alive a bit longer. Here we specify what how the pipeline must look like. So this class here contains all the information about our pipeline. We tell the factory, please use this characteristic to create the pipeline. And then we run it in a different thread as a task. We do that also with a second factory, and the only difference being that it of course uses the other pipeline handle and a different characteristic. The characteristic in this case is very simplistic. Namely, you can see it here. It only implements the initialize function. And then even they both call the same function. Except the last parameter is 1 or 2. Which I'm going to rename into 0 and 1, because also in the readme I called all the 1s here 0 and all the 2s I called 1. I think it would be a good thing to do that in the code as well. In fact, let me do that right now. I think that this window.h defines the whole application basically, apart from, of course, from the engine itself. So I don't think that this variable is being used outside of this file. And I can just do a replacement in the whole file of in pipeline factory 1 to 0. And then again, but now I rename number 2 to 1. And then I have to do the same thing for the characteristic, for example. So I rename 1 to 0. And then again 2 to 1. You have to do it in the right order, of course. Did I have more zeros and ones? Well, here I can change this to 0 and 1 now. I think these are the only ones. We have characteristics, pipelines, and the graphics pipeline. We change this number 1 into a 0. And again, change this 2 in a 0, in a 1, I mean, like that. Initialize X, that's the command call, and now the pipeline values changed for, one is subtracted from the value. So you have to take care to change the code correctly. Change the code, what is the word? Correspondingly cannot be a right word. Corresponding? Just corresponding, I think. So this value is only used where the code differs. I think already outside of it. So almost the same initialize for both pipelines, except that I swapped the uniform buffers, top and left. What this does is it will assign set number 0 to the top buffer, and if you do it the other way around, it will assign number 0 initially at least to the left buffer, and then 1 here and 1 to the top. And bottom will always get 2. Just like the comments say everywhere. And then later on here I'm using differentiator code. So pipeline number 0 now. Oh, there's another thing that we can rename then. The shader code is also numbered 1 and 2. Let me call this 0. It's 0. Let me first do that. That's all, okay, and then the vertex 2. It's renamed to 1. And frag 2 is renamed to 1. And then actually I even have here the actual code, most of which is now generated. So this is all commented out. All of this is now being generated. And let's also rename those. So I have a triangle 1 shader for fragments. Yeah, I think that's really the only places, so I can just do that globally. Triangle 1 to 0 and again for 2 to 0. Good, that has been renamed. Pretty sure I can try to recompile it, see if there's maybe forgot something, or there's another file that uses these enumerations, but I don't think so. Nope, it just compiled. And there's a race condition that sometimes when I run it, it breaks. Top works, but bottom and left don't work. Yeah, we said that it was sometimes. I think I did. There we are. So it just works as before. I think this picture is pretty correct, because yeah, I do have 2 different pipeline layouts, but we only do have one shader resource. So these shader resources are represented by, yeah, for example, the uniform buffer, or what is it called? Top? Like this? Nope. Maybe like this? Also not. I give up. Oh, it was just buffer. There's no uniform in it. Yeah, M top buffer. Yeah, so this is the window class. We have only one window, and we have only one of these, and we have also a texture somewhere. It's probably called sample texture. Also part of the window class, and also one instance that refers to the texture. You gotta wonder if these things then also wrap a handle, right? Let me check. Yeah, kind of. It's a unique image view and sampler. The texture is really a combined image sampler, so the handle, they are just wrappers for the handle. This is a wrapper for the image and the sampler, and then the other things were they wrap. Find it first. Because that's this. Yeah, that doesn't contain anything, but the base class does. I hope. Yeah, okay, this is the handle, but we have multiple handles. Why? Because we have multiple frame resources, as they are called. The ideas of frame resources is that you use a frame resource while drawing a frame. So what I do is I use a frame resource, and then I tell the GPU, please draw this, and then I'm not allowed to change that again. So it while it's drawing, I'm not allowed to change it. So in the case of a uniform buffer that I want to change every frame, I would have to wait until the frame is completely done and the GPU is done drawing it before I can change the value of the uniform buffer. So what we do is we have more than one frame resource, even though the user only sees a single uniform buffer. Well, my user then, if you use my Vulkan engine, if you write for Vulkan yourself directly, then you have to deal with every gory detail, and you're also aware of the fact that you have multiple uniform buffers, and you must manually switch. So that's why you write Vulkan engines. So user does not have to be bothered by that kind of details anymore. But the idea is that we have multiple buffers, and then I just write a float value into it. I tell to the GPU, please draw this, and then I write a value to the next uniform buffer, the next frame resource, and use that for the next frame. Well, right now I did not implement that. Hi, Demir. Yeah, what I said, right now I'm not supporting this. So I really have only one frame resource. Haha. So the vector has a size 1. Not really, but I'm just using index 0. So what we really have here is a memory uniform buffer. And that, hopefully, that's this structure. And that has a pointer to the CPU memory that we can write to. It does not have a handle, apparently. Well, it does not wrap a handle, maybe it doesn't have to. That would maybe also a little bit difficult, because you cannot and you do not want to have a small memory allocation that you can share with the GPU. Well, that's what it is, right? The GPU can read the same memory. The GPU only supports a limited number of memory blocks that you can share with between the GPU and the CPU. So you need something like VMA, stands for Vulkan memory allocation library, I guess, to do all kinds of difficult things, which comes down to that you allocate a large block and then allocate from the large block a little block using VMA. So then the GPU thinks it is only one block, but from the user of VMA has the feeling that it has multiple blocks, while still having the efficiency that you need of using larger blocks. In other words, we cannot have a handle. You cannot have one handle to our uniform buffer, which would include a handle to the memory, because there is only a handle to a large block. So that all of that stuff is hidden, I guess. I mean, you are looking at code that I wrote, but my memory is non-existent. So for me, it's like I try to be perfectionist and make it work. Try to make it work in a way that I not ever have to look at it again, if you understand what I mean. If it works, it must really work, and then it's no problem of me, right? So okay, but from, you know, if we want to understand what we're doing here, the uniform buffer base here wraps basically pointers then to the uniform buffer memory that we can write. That would then basically be the pointer points to a struct, right? This the struct of it points to a top position struct and a left position struct and a bottom position struct. So I can just cast it, or it's being casted for me, of course, by this template class here. You can see that as well. Good template. No, I don't see it. Well, I don't know. Somewhere buried is a cast of M pointer, I'm sure. Actually, there isn't. There is not yet. I have not implemented that. Nope. This is window.h and M pointer is used raw by the user still. And I can't type. And there is no M pointer being used by raw, but come on, it is. top position. Now here's the cast. Okay, I'm not accessing endpointer, but I'm calling an accessor for the pointer. So yeah, in the end, this must be hidden, obviously. And I guess the reason it's not hidden is because also I did not implement the shader resource stuff yet automatically. So in the end, I'm going to turn this into much simpler looking access to mtop buffer, where the fact that I'm using a certain frame resource is hidden, and then the whole casting is hidden as well. Right now it still looks a little bit hairy. Okay, so where were we? I think we are at 9 PM and I still didn't eat dinner. So maybe I should stop here and go eat or go make dinner. So let me summarize so that at least I have something, achieved something that I can continue from in after dinner or something. So yes, per pipeline layout I can swap my set indexes. I cannot swap the bindings. And we didn't look yet at the exact code that causes these links here, which would be the update. So that would be the next step done. So let me add a to do, look at the code that makes that link, update something, update descriptor set. Yes, and then we have yeah, and after that I have to look at how the pipeline themselves are being created. I think I need to realize the no, I don't. Or I do. Yeah. I think it creation of the pipelines themselves also take handles. They take pipeline layout handles, right? So just parcel a pipeline layout handle together with some other information like handles to the compiled shaders. I can only compile the shader after I generated the GLSL declarations of the used shader resources, which in hardcode the or fix the set index numbers and the binding numbers. Well, they are pretty much fixed now, right? Although I do need a coupling, say between bottom and the 0 here, and the left and the 0. while here I have, no, here top is always linked to 1 here. Yeah. I want to change that, right? I wanted to change that, but no, that's not possible. It's just simply not possible. Not if I use the same handle. Because what happens is that at the moment I try to create this pipeline layout, it's going to say, well, that's a T plus U and 2 times a U. I already have that. And I'm going to use the same thing, which enforces me to use the same bindings. You can just change the set. I don't know why I would do that actually. I mean, the engine can also say, well, these are so equivalent. I'm going to use the same order, and then you will have to deal with the same handle for the pipeline layout. Which makes, which in a funny way breaks my test, because I'm trying, you know, I'm trying to let it generate 0, 1 and then swap stuff. But while I'm doing that, it says, yeah, but I found something that is much like it, and the whole swapping is nonsense, so let's not do that. That's what's going to happen, I think. It's just simply going to throw away one of the pipeline layouts and say, screw you, I'm going to use a single pipeline layout. And you will just have to stick to these bindings and set numbers. So in the end we will not have pipeline layout 1, I think. I think the remaining problem that I have now is that I still have leftover code from before. And that code from before, that old code, does all kind of swapping, and there is no swapping possible anymore, except that I don't know what I get. I mean, depending on the race condition, either this one finishes first and that one copies it, or this one finishes first and that one copies it. So I'm either end up with this layout or with that layout, and I don't know which, but it is the same for both pipelines. So yeah, we just have to work it out. But I should eat, and I'm ending the stream now. Well, thank you for watching, and I'll see you